Assalamualaikum and hi everyone. Today we will start with chapter 1, Introduction to Power Electronics. Okay, this is the outline for this chapter. Okay, so first we will cover the definition of power electronics, followed by an electronic switches, which includes uncontrolled, semi-controlled and fully controlled switch, and how to select the switch for our applications. Okay, and finally we will cover the applications of power electronics. Okay, and at the end of this course or of this subject, students should be able to investigate switching characteristic of basic solid-state power device, operating principles, advantages and disadvantages of basic power electronics technologies. Okay, so this should be your first course outcomes, right? Okay, power electronics is around us. It includes applications in which circuits process from milliwatts until gigawatts. But what is power electronics? How it works? And why should we use power electronics? Do you have any ideas? Okay, so in this class, we will try to find out the answers for these questions, okay? Okay, power electronics is actually a combination of a power with an electronics parts and a control system. Okay. So for the power, it involved with the static and rotating equipment of power generation, transmission and distribution. For the electronic parts, it involved with the solid-state device, which is used to match the voltage and current requirements to the loads, while the controller is used to help smoothing the process and control the flow of an electrical power from the source to the load. Okay, here is the basic block diagram of the power electronic system, which involve a source or a power. Okay, and then we have a power converter. Okay, and then a load and also a controller. Okay, so in general, we can say that the main function of the power electronics is to transform or to convert an electrical power from one form to another form using an electronics device. Okay, so here we have a power converter, which is used to match the current or voltage requirement from the source to the load. Okay, and for this power converter, it will be either from DC to DC, DC to AC, AC to DC, or AC to AC. Okay. This is the example of power electronics application. So here we have a power source at the left, which is coming either from a conventional source like a coal power plant or from a renewable energy sources like solar PV, wind and nuclear. Okay, and then we have a utility grid for transmission and distribution here, and a variety type of loads on the right. Okay, and then in between the source and the utility grid, we need a converter or a transformer to step up or to step down the voltage. Okay, now let's make a solar PV as an example. So solar PV produce DC voltage. In order to be submitted for the AC transmission, it needs to be converted to an AC form first using an inverter. And then if you want to power up the DC load here, a rectifier is needed, and if it is for an AC load, then an AC voltage controller is needed. Okay, so we can see that the converter is very important in our daily lives to avoid equipment damage. Okay, and if the converter is used to convert from DC to DC, so we can call it as a chopper, and if it is from DC to AC, it is known as an inverter. AC to DC, rectifier, while if it is from AC to AC, so we can just call it as an AC voltage controller. Okay, next, electronic switches. Electronic switches play a vital role in power electronic systems. It represents the heart of power electronic systems. But why do we use switches? Okay, we use switches because of its power handling capability. It can regulate voltage or current even in high power applications. Besides, we are working in switches state to reduce power losses as an electronic switches working in two states only. Okay, so we have on state or conducting and off state or blocking. Okay, and for the on state, the voltage across the switching device here is 0. Okay, so the current can flow. Alright, and then for the off state, the current flow is 0, means no current is flowing, and there's a voltage drop here. Okay, so for both cases, P is given by V times I, so it is equal to 0. So why 0? Again here, because the voltage drop is 0, so V is 0, so power is 0. And for the off state, current is 0, I is 0, so again we will get P equals to 0. Okay, so for both cases we can say that power losses is actually or ideally 0. Alright, but now let's talk about a switch in practical. So practically, a switch has switching losses during the transition from the on state to the off state and vice versa, as it cannot change the state instantaneously. Alright, so it takes a finite time to turn on and a finite time to turn off, which in turn produce power dissipation. Okay, so this is the transition during the on state and off state. Alright, so for the practical switch, we need to consider both conduction losses, okay, for the conduction state here, plus the switching losses. Alright, so the total losses will be on state loss plus turn off loss plus off state loss plus turn on loss. Alright. Okay, so as in brief, electronic switches are used in power electronic system because of these advantages. Okay, so it has high efficiency because of low power dissipation as mentioned earlier, and then it has high availability, high flexibility and reliability. It means that it requires less maintenance, therefore it has a longer lifetime. Okay, and then it is low cost, small in size, so that the weight is reduced thanks to the continuous development or advancement in semiconductor technology. Alright, and finally it is environmental friendly, so it means that no hazardous and no CO2 is produced by switch. Alright, so that's all for today. We will continue with part 2 of chapter 1 in the next video. Alright, with that, I thank you. Bye bye.